Imagine relaxing on a low-lying coral island, nothing but endless blue ocean. Actually, some 65 million people live on such islands, think the Maldives or Australia's Cocos Keeling group. But under climate change, many of the islands are in danger. Rising sea levels, storms, other threats are taking their toll. Also at risk are maritime boundaries, including Australia's. From Sydney University's School of Geosciences, Dr. Thomas Fellows explains.
A low-lying coral reef island is an island that forms on top of a living coral reef with sediments from the living reef itself. They're made of skeletons and shells of different living biota, and they're usually within a couple of meters of sea level. They're found right across the tropics on reefs across the world. The most well-known area would probably be the islands on the Great Barrier Reef. There's plenty of low-lying islands there, but there are other islands that are further offshore, which are the ones that I research. In terms of climate change being not just one threat, it's a combination of threats. So that's kind of what this paper really does. It brings those biological threatening and physical processes together. But what we mean by sort of destabilizing islands is that are they going to succumb to the compound effects of climate change? Is sea level rise going to flood them? Are storms then going to be able to erode them? The whole sort of premise of this methodology, this new classification, was to look at the most important factors that dictate risk or vulnerability. Then on a scale of say 1 to 5, 1 being the lowest, 5 the highest, rank each island based on their exposures. So for example, sea level rise. If sea level rise was lower than the global average, we assign a lower risk value. If it's higher, we give a higher one. And through that sort of simplified process, we did it for various threats and various characteristics, and that gave us a total value. We could sum it together and it would give us a number. So a storm is quite a short time scale event. It can erode, it may even bring new sediment to the reef, to the island. Then we look at things like slower processes like sea level rise, relatively slower, that the islands themselves could change into a different state. If the water is higher, more wave energy can reach the shore of the island. Maybe the island changes to a new state.
Up to 700 islands across the globe could be affected by such events, and Dr. Thomas's research applies to each and every one of them. Many are important markers of maritime jurisdiction. They grant an owner the right to use the area's natural resources, such as fisheries, minerals, and petroleum.
This study just looks at 56 islands, but we use open access imagery and climate models. It has global application. You could use it on any island. We're looking at the offshore ones, which have been mapped because they have strategic importance. And we looked at 56, but there are more islands, but they were representative of the types of islands you find across the whole of Australia. This project was funded by the Australian government, Geoscience Australia, and they wanted a way to identify the most at-risk offshore islands that support Australia's maritime zones, maritime jurisdiction. It was a method of being able to focus in on the at-risk islands, and then that will inform them in their decisions going forward with how to manage these systems. So there's the UN Convention on the Sea. Most countries in the world signed up to that. And within that legal framework, there is a clause that states that if you have a reef with an island on it, and that is part of your sovereign nation, you can draw maritime zones from that reef and island to up to 200 nautical miles. But in the Australian context, these features actually provide 15% of Australia's maritime jurisdiction across those zones I've spoken about. It's about 1.2 million square kilometres. The idea of how to draw these zones is based on the fact that an island is above high water mark. So if you move that high water mark, there is potential risk to losing those zones.
Well, our exploration doesn't end here. Why not stay informed of the latest developments in science by subscribing to our channel?